The periodic table introduction lesson. It is stated on your syllabus that you need to know how the periodic table is actually arranged, and it is arranged in increasing atomic number. So that is something we talked about in the lesson on atomic structure. So the atomic number is the number of protons. So as you can see, it goes 1, 2, 3, 4, 5, 6, 7, and so on. Now you might say, why is it not arranged in increasing atomic mass? Well, that's because there is certain positions where this rule is broken. A simple example is argon is 40, and after it is potassium, which is 39. That technically would break the rule. And also tellurium is 128 and iodine is 127, yet it's after tellurium. So the atomic mass doesn't work, but the atomic number does. Now the table is arranged in groups which are vertical and periods which are horizontal. I did briefly touch this in atomic structure. So the groups go down this way, and the group number represents the number of outer electrons in an atom and determines the chemical reactivity of the atom. So elements in the same group have similar chemical reactivities. They obviously have trends, such as group 1 becoming more reactive down the group, but they react in a similar way because they all have one electron in the outer shell, which they need to lose, as an example. Now, period numbers go across. The first period is hydrogen and helium, and the second one is lithium, beryllium, boron, and so on. And that's the third one. So you're basically going 1, 2, 3, 4, 5, 6, 7. Now, the period number represents the number of shells. So, for example, lithium is 2, 1. 1 second. Back to our lesson. So the period number represents the number of shells. Now, you should be able to identify metals and non-metals. So this is the zigzag line that you can see here. So everything on the left is a metal. It is labeled in this light blue color. Everything on the right is technically a non-metal, but the elements which are circled in these green boxes are called metalloids, which means they're half metals, half non-metals. So they can behave as a metal or a non-metal. That is not something that you specifically need to know for your syllabus. It's just an interesting point. So as you can see, down. So astatine and tennessine are non-metal solids. Okay, so the zigzag line goes down here like this. Now, what you're supposed to know is about the acid-base character of the oxides of the metals and non-metals. So let's have a look. The key properties to look out for. As we said, we have a zigzag line here, and we can have metal oxides or non-metal oxides. So metal oxides tend to be are basic. Okay, they behave as bases, whereas non-metal oxides are acidic. Very easy to remember this. So a non-metal would be something such as sulfur, so SO2, sulfur dioxide, or perhaps CO2, carbon dioxide. Now, the reason these are acidic is that when they react with water, they form acids. So CO2, for example, plus H2O can form H2CO3, carbonic acid. Very unstable acid, but nevertheless. Then the SO2 is obviously a famous reaction because it causes acid rain. So this actually goes to H2SO3, which forms sulfurous acid, which later gets oxidized to sulfuric acid. You will cover this in a different topic, but the main point, takeaway message, is that non-metal oxides are acidic. On the other hand, metal oxides are going to be basic, which means something like, say, sodium oxide, Na2O, can react with water, and it actually forms sodium hydroxide with a 2 here to balance it. So these are going to be basic. These are some other key properties of them. So metals are going to be metallic, non-metals covalent. So metals are good conductors of electricity, whereas non-metals are poor. Metals react with acids if they're more reactive than hydrogen, but non-metals do not. And furthermore, metals, as you know, are malleable from the previous lessons on bonding. They can be bent or shaped with high melting points, whereas non-metals tend to have low melting points and be flaky and brittle. These are just generalizations there. The main takeaway message, as per your syllabus, is the following message right here. Understand how electrical conductivity and acid-base character of oxides classify metals. So if you're conductive, you're a metal. If you're non-conductive, you're a non-metal. If you're acidic, you're a non-metal oxide. And if you're basic, you're a metal oxide. Those are the key points. And it says identify an element as a metal or a non-metal. Well, I already told you the left side of the metals, the right side of the non-metals. The final points here, you need to deduce electronic configurations. I actually did this in the atomic structure lesson about how the first shell has a maximum capacity of 2, then the second shell is 8, and the third shell is 8. We talked about how the group number represents the number of outer electrons, and the period represents the number of shells. The last 2 points here, so this one here and this one here, as I said with this one, if you have the same number of electrons in your outer shell, you have the same similar chemical properties. Now for the noble gases, we can have a look here. So noble gases are group 0. They're monatomic, which means that they exist as single atoms, and they're colorless and non-flammable. Now, because they have a full outer shell, they're inert. They're extremely stable. They don't want to gain and lose electrons or share electrons because they already have the desired electronic configuration. So helium can only hold 2 electrons and is perfectly satisfied. Neon would be 2,8. And the last one on your syllabus would be argon, 288. Do not worry about these because you're only supposed to know up to the first 20. If you are interested, however, there's a formula, 2n squared, where n equals the shell number. This formula is actually correct even in A level by showing you the maximum number of electrons a shell can hold. So the first shell will be 2 times 1 squared, which will be 2. The second shell will be 2 times 2 squared, which is indeed 8. But the third shell would be 2 times 3 squared, which is actually 18. That's the reason you see the 18 here. But as I said, that's non-examinable. So that is just a short section on the introduction of the periodic table, knowing the chemical reactivities. So that's the end of this lesson.